since 2014 with Kurt Rohoff and Dave Cousins. We've been working on Palisade, so we created Palisade, and this is a predecessor of OpenFHE, the new library.
So Duality Technologies has been developing open source homomorphic encryption technologies, open source privacy technologies for several years. In fact, pretty much the past decade in our core tech cryptography team. We've also been part of a larger community developing open source homomorphic encryption technologies, including the HElib library and CKKS libraries, other large, well-established libraries.
So I'm Dave Cousins, and I'm one of the original authors of Palisade, and I am the head of labs at Duality. And as such, I have done a lot to help bring together the various people involved in OpenFHE. I tend to develop the applications that are used and distributed with the OpenFHE platform. And they are extensions of the Palisade library and will be used to determine the applicability of FHE for real-world applications.
Hi, I'm Andrzej Kim from Samsung Advanced Institute of Technology. I'm a co-author of CKKS scheme and was a developer of the Heian library during my PhD program. I've been a co-developer of Palisade and a member of the Palisade crypto team since 2020.
Hello, this is Daniele Micciancio. I work on lattice cryptography and lattice algorithms. I have been involved with the OpenFHE project and its precursor, the Palisade library, for many years. This library implements many algorithms that I worked on in the past, including the few homomorphic encryption scheme with fast bootstrapping for bit-level computations.
So my involvement with FHE, OpenFHE is mostly on a sort of a theoretical and algorithmic level, in the sense that OpenFHE actually implements FHE algorithms that I co-invented with other people more than a decade ago. And we've been sort of working on optimizations to these algorithms, a lot of which were incorporated into OpenFHE.
In HElib, in CKKS, into a converged, more robust library called OpenFHE that is going to support both Duality products and the broader open source FHE community for the coming generation.
My work on OpenFHE has revolved around the usability aspect as well as the documentation aspect. So from a documentation standpoint, what we found in the past is that a lot of these libraries, they are very difficult for new users, especially those who don't have experience with FHE, to get involved in.
As we have developed experience over the past years deploying open source, commercial ready, production ready, homomorphic encryption, we've learned a set of best practices for how to build better, more robust, more proficient, more capable sets of privacy technologies in homomorphic encryption.
And there are certain things we observed that there are certain things we can do better. And for instance, now what's becoming very important for fully homomorphic encryption is hardware acceleration. Because one of the limitations of FHE is the speed, or it's something, the faster we can get FHE working, the more practical applications we can get. And hardware acceleration is something that can enable broader use of fully homomorphic encryption.
A lot of HE libraries are built for HE developers, I would say, but the goal of OpenFHE is to make it accessible to general software engineers, to perhaps machine learning and data science people, to get an exposure to these concepts without necessarily having to be an expert in FHE.
There are several FHE libraries out there, but FHE has a usability crisis. You know, these libraries, they all work on different platforms, they implement different features, different APIs. So what I think is crucial to move FHE to the next stage is to have a unified API, programmer-friendly and user-friendly interface, and really like a team of sort of intellectual sort of firepower behind this whole project. And I think OpenFHE has all of that.
So OpenFHE was developed by a team of researchers from all over the world, people who have developed other libraries previously, and have come together to provide a unified base of code that supports a wide range of encryption schemes and applications.
The other major contribution of OpenFHE is about having a general FHE toolbox with various schemes, the most common schemes. Our goal is to support scheme switching so that one can always use a certain scheme for a given part of computation and then switch to another scheme. These are probably the two major differences in the OpenFHE project.
OpenFHE includes many other useful FHE schemes. Schemes to efficiently perform arithmetic operations on integer vectors, or even schemes to perform approximate real or complex valued computations. A core feature of OpenFHE, besides providing state-of-the-art support for each of these schemes, is to make the schemes interoperable, offering powerful sound methods to convert between them. Now, this will enable a wide range of applications that make use of integer, real, or logic operations, all within the same program.
The OpenFHE library is an overhaul of Palisade with new functionalities, including recent improvements of the main HE schemes and full RNS-ETS bootstrapping. OpenFHE also includes a new feature, hardware abstraction layer, that supports multiple hardware acceleration backends. I'm excited to be a part of this project.
The first open source repository that's really understandable, easy for programmers to use, and it's the combination of so many different people that have worked on it, experts in the field, really strong software developers. And yeah, we're really excited to release it.
We are building technologies to promote secure collaboration, and better be that this project is itself collaborative. So indeed, I think OpenFHE is sort of an amalgamation of the earliest FHE library that was out there, which is Shai Alevi's HElib, one of the most well-designed FHE libraries out there, which is Palisade, and it incorporates several other features that is not in either of these two libraries. So yeah, I think it's pretty impressive. I'm looking forward to it.